Let's go to next application of Biot-Savart Law, magnetic field due to a solenoid. A solenoid is a helical winding of an insulated copper wire wound on a cylindrical frame, usually of circular cross section, as shown in figure 1. Now we are going to calculate magnetic field inside a long solenoid. Yeah, consider a solenoid, very long solenoid of radius A, as shown in figure 2, radius A, and that carries current I in anticlockwise direction at the right end. Those sign represents the direction of current. This cross sign represents the current is into the plane of paper at that point, and those dot signs inside the circle represents current is out of the plane of paper at that point. So at the right end, the current is anticlockwise. Yes, we are going to use Biot-Savart Law to find the magnetic field inside the solenoid. Let the field point P lies on the axis of the solenoid. To use Biot-Savart Law, we need to consider elemental length. Suppose elemental length dx at point A. Then join A and P such that AP is equal to R. Remember, AP is equal to R, and AM is equal to OX is equal to radius of the solenoid. OM is equal to X, and OP is equal to X naught. That field point P is at a fixed distance X naught from one end of the solenoid. The angle AP, check that figure. The angle APM or APO, you can say, is phi. Now, remember that the elemental length of solenoid is just a circular coil having n turns. That is the circular coil having n turns. So the magnetic field at point P, due to this elemental length, which is a circular coil, that we have already drawn. So we can use the magnetic field at an axial point of circular coil as magnetic field due to this elemental length in this case. That formula is mu naught Ni square upon 2r cube. Yes. In that case, this expression represented the total magnetic field, but here that circular coil is only elemental length of the solenoid. So we write here dB. Okay, in this case also, we convert variables and integrate to get the total magnetic field. Right? Let me share. Here, capital N is the total number of turns in that elemental length. If small n is the number of turns per unit length of the solenoid, then from the definition, it will be number of turns per unit length, and total n will be equal to small n times dx. So the above equation is converted to this one, dB is equal to mu naught n dx I a square upon 2 r cube. Just capital N is replaced by small n dx. Now we will convert the variables using the geometry of the figure. Yeah. Check the right angle triangle MPA. In this triangle, we have cos phi is equal to r by a, h upon p. That means hypotenuse upon perpendicular. This is hypotenuse, and AM is equal to a is perpendicular there. So this implies r is equal to a cos phi. R is equal to a cos phi. Next, you want to convert dx, and dx is x variable is included in side MP of the triangle MPA. So we use ratio, trigonometric ratio MP upon AM, that is B upon P, which is cot phi. Now from the figure MP is equal to AM cot phi. Yeah, from that trigonometric ratio. From the figure, check MP is equal to MP is this length is total length x naught minus x, and that x naught is fixed or constant. So the derivative of this x naught will be 0. But x is variable because we can take dx throughout the length of the solenoid. So after the differentiating, we get minus dx is equal to cot phi. Derivative of cot phi minus cosec square phi. Derivative of x naught is 0, so minus x gives the minus dx. Yeah, after simplifying, you have dx is equal to a cosec square phi d phi. Now you can substitute the variables in equation 1 and get the expression as mu naught n I in place of dx. We substitute this value a cosec square phi d phi, and in place of r substitute a cos phi and simplify to get, just simplify this expression to get dv is equal to mu naught n over 2 sin phi d phi. Now your job is to just integrate this equation, because this flux density is due to that elemental length only. To get the total magnetic field, you have to integrate this equation throughout the length of the conductor in angular limits. That is from phi 1 to phi 2. Okay. Now, yeah, integrate this equation and substitute the value of dv from equation 2. Take the constants out of the integration sign and integrate to get b is equal to mu naught n I by 2 cos phi 1 minus cos phi 2. This integration is just similar to that of the case of straight conductor. Integration of sin phi is minus cos phi, and after substituting the limits, you get mu naught n I by 2 cos phi 1 minus cos phi 2. This is the most general expression. That is, this is true for a solenoid of finite length. Now, as special cases, consider a solenoid of infinitely long solenoid, which is infinitely long. In this case, phi 1 tends to 0 and phi 2 tends to 180 degree. Now substitute these values in equation 3. Yeah, to get this, p is equal to mu naught n I by 2 cos 0 minus cos 180 degree. Substitute their values and get the result. B is equal to mu naught Ni. Remember, this mu naught is permeability of free space, means the inner part of the solenoid does not have any solid or any other medium, just air cored solenoid. This mu naught is permeability of free space. N, number of turns per unit length of the solenoid. I, current, which all are constant. So magnetic field inside a long solenoid is constant. This has many applications. Now, if the solenoid is semi-infinitely long, that means we are calculating magnetic field at one end of the solenoid. Phi 1 is equal to 90 degree and phi 2 tends to 180 degree. After substituting these values in equation 3, we get B is equal to mu naught Ni by 2. Check these two expressions. What are these expressions saying? The magnetic field at one end of the solenoid is half of that in the middle of the solenoid. Again, I want to remind you that remember those results for some theoretical problems or numerical problems. Thank you, and this is the end of applications of Biot-Savart Law. If you need any other topics for discussion, you can write in the comment section. I will check and try to solve your problems.